extraordinary and shocking discovery, brain cells in a dish exhibit sentience. By learning how to play a video game, Pong, it's as if that wasn't bizarre enough. The researchers are now looking to experiment with getting their model brain drunk. Neurons in a dish can learn to play the classic video game Pong. A bizarre experiment reveals a breakthrough that may revolutionize how we study the way the brain works. The setup creates for the first time a truly living model brain, but to directly run experiments on rather than relying on drawing potentially misleading comparisons with computer systems. The international team created their so-called dish brain by taking brain cells from embryonic mice and those derived from human stem cells and growing them on top of a microelectrode array that can both stimulate them and read their electrical activity. In total, dish brain is made up of some 800,000 brain cells, the researchers reported. Signals sent to the cells via the microelectrodes were used to introduce the model brain to Pong, the table tennis-like arcade game. First releasing in the 70s, it was released in the 70s, in which players move a paddle to keep a ball bouncing back and forth across the screen. By firing electrodes on different sides of the array and employing different frequency signals, the team were able to represent which side the ball was on and how far it was from the paddle. At the same time, feedback was sent into the array to make the cells act as if they were the paddle, thereby teaching dish brain how to return the ball. Paper author and theoretical neuroscientist Professor Carl Friston of University College London said the beautiful and pioneering aspect of this work rests on equipping the neurons with sensations and the feedback, crucially the ability to act on their world. Remarkably, the cultures learn how to make their world more predictable by acting upon it. This is remarkable because you cannot teach this kind of self-organization simply because, unlike a pet, these mini-brains have no sense of reward and punishment. Instead, Professor Friston explains it's thought that cells at this level naturally work to try to minimize the unpredictability of their environment. The study was led by neuroscientist Dr. Brett Kagan, Chief Scientific Officer at Cortical Labs, which is working to build a new generation of biological computer chips. He said, "We have shown that we can interact with living biological neurons in such a way that compels them to modify their activity, leading to something that resembles intelligence. Scientists have been able to mount neurons on arrays and read their electrical activity for some time now, but this is the first time that researchers have managed to stimulate such cells in a meaningful and structured way." As Dr. Kagan noted, in the past, models of the brain have been developed according to how computer scientists think the brain might work. That is usually based on our current understanding of information technology, such as silicon computing. But in truth, we don't really understand how the brain works. Building a living model brain thus allows scientists to conduct studies on real brain function rather than relying instead on potentially flawed analogies to other systems. In fact, the team has found ways in which dish brain behaves completely differently to how computers operate. Dr. Kagan explains, when we presented structured information to disembodied neurons, we saw they change their activity in a way that's very consistent with them actually behaving as a dynamic system. For example, the neuron's ability to change and adapt their activity as a result of experience and increases over time, consistent with what we see with cells' learning rate. According to the team, dish brain will pave the way for completely new approaches to learn what is going on inside the brain. Paper author and computational neuroscientist Dr. Adil Razi of Australia's Monash University said, "This new capacity to teach cells cultures to perform a task in which they exhibit sentience by controlling the paddle to return the ball via sensing, will have far-reaching consequences for technology, health, and society. We know our brains have the evolutionary advantage of being turned over hundreds of millions of years for survival. Now it seems we have in our grasp where we can harness this incredibly powerful and cheap biological intelligence. In fact, the team have already planned their next experiment on dish brain. They want to get it inebriated on alcohol. As Dr. Kagan explains, we're trying to create a dose-response curve with ethanol, basically get them, the neurons, drunk and see if they play the game more poorly, just as when people drink. Just as the team can experiment with giving their brain in a dish alcohol, they can also use it to see how the brain might respond to more medicinal drugs or even gene therapies without needing to resort to animal testing. Professor Friston said the translational potential of this work is truly exciting. It means we don't have to worry about creating digital twins to test therapeutic interventions. We now have, in principle, the ultimate biomimetic sandbox in which to test the effects of drugs and genetic variants, one constituted by exactly the same neurological elements found in your brain and mine. Cortical Lab's Chief Executive Officer, Dr. Han Weng Chong, said, "Dish Brain offers a simpler approach to test how the brain works and gain insight into debilitating conditions such as epilepsy and dementia." Dr. Chong said that the discovery was exciting, but very much only the beginning. He explained that this is a brand new virgin territory. We want more people to come on board and collaborate with this, to use the system that we've built to further explore this new area of science. As one of our collaborators said, it's not every day that you wake up and you can create a new field of science. The full findings of the study were published in the journal Neuron. This is on Express UK by Ian Randall. Please leave your comments. Thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.